5.2 Critical points. If a function f is continuous over the interval a to b, then f has at least one minimum value and at least one maximum value on a to b. Some terminology here. Global versus local extrema, absolute versus relative extrema. These are two different ways of saying the same thing. I'm going to be using this language here, absolute or relative, but absolute is the same as global. Like these are the same. Global absolute is the same. Local and relative, they're the same thing. But I'm going to use the words absolute and relative. And when we say the word extrema, all they mean is a maximum or a minimum. We're going to show some examples here. So absolute, if we're looking at this graph here, what is the absolute max, the absolute highest, and the absolute lowest on this graph here? Like looking up and down. You can see this point right here. This is the highest point on the graph. That's the absolute max, the absolute maximum value on this graph right here. This right here, you see this is the lowest on the graph? That's the absolute min, absolute lowest of this graph. That's what absolute means. So what relative means, like a relative min or a relative max, is you're just lower or higher than the points that are directly nearby you. So if you take this point here, right? It's kind of weird because there's a kind of jump going on right here. But if you see right here, this point is lower than the values coming in from the left. And then even though there's like a jump here, the domain still exists right here. And it's lower than the values coming in from the right. So this is also a relative min. At this point right here, you can see there's this point discontinuity here, but this is also a relative min because you can see that this point right here is lower than the points on the left, directly to the left of it, and the points to the right of it. This one here is going to be more straightforward. This is a relative min because you can see this is at the bottom, a bottom of like a little curve here, and it's lower than the values directly nearby it. So again, we're going to go do some practice. Find all extreme values, identify the type and where they occur. Find all extreme values, the value of the point, and then where they occur. So I always like to start off with the absolute max or min. So the absolute max here, the highest point on the curve on this graph, you see it's right here, and that's a y value of 5. Of 5 when x is equal to 0. The absolute max is 5 when x is equal to 0. When x is 0, y is 5. The absolute max is 5. Let's look at the absolute min. The absolute min is, you see right here, it's a closed hole. The absolute min of 1 when x is equal to -3. Let's see here. Let's see if there's any relative maxes right here. So we do have this point. So this point here that we identified as the absolute max, this is also technically a relative maximum because it's higher than the points nearby, but it's already the absolute max, so we don't need to write a relative max there. Let's see about relative min. So this point right here would be the relative min because this value right here is lower than the points nearby it. This is the lowest point on the points directly near to the left and right of it. So relative min, and that's a y value of 2 when x is equal to +1. Let's look at this one here. Let's look at an absolute max. The absolute max of this graph is right here, of 3 when x is equal to -1. Let's see if there's an absolute minimum. See, the lowest point is right here, but you see how this is an open hole? If the lowest point on the graph is an open hole, you technically never ever reach this point, so it's not an absolute minimum. You're approaching -3 here, but you never get there. So in this case, there's actually no absolute min because there's an open hole. Let's see if there's a relative max. Relative max will be right here because it's higher than the values right next to it. Relative max of 1 when x is equal to +1, and then a relative minimum of, let's see, relative min, no relative min right here. X is 1 is not a relative min because you see the closed hole is up here. At 1, this is the point here. And the points to the left and right are lower. Let's take a look at this graph here. Look at like all the tops of the mountains, the bottoms of the mountain peaks here. So you see like this could be, well, this looks like to be the absolute max. This looks like to be a relative min, relative max, relative min, another relative max. Let's see these derivatives at these points. Here it's a horizontal tangent line, right? So f prime is equal to 0. Same thing here. F prime is equal to 0, horizontal tangent line. Same thing here. Same thing here. But here the f prime does not exist. So this is important to know. If you notice, all the relative min and maxes, they all have a derivative of 0 or d and e. That's interesting. Let's go to the next page, the very top. So a critical point. A critical point is a point that has a possibility of being an extrema, which is a max or min. How do you find a critical point? Whenever f prime does not exist, or f prime of x equals 0. Examples here, find all critical points. So let's first find the derivative, and then we gotta set it equal to 0. So f prime of x is equal to 1/3 times 3 is just, is just 1, so you leave left with x squared minus 9. And then you want to set that equal to 0 because we're finding the critical points. X squared is equal to 9. X is equal to, well, you square root both sides, so x is equal to plus or minus 3. Question 4 here. We have to find the derivative, but first we can rewrite this as parentheses 4 minus x squared to the -1/2 power. So g prime of x using the power rule and chain rule is equal to, bring the -1/2 down, times parentheses 4 minus x squared, -1/2 minus 1, which is -3/2, and then you multiply by the derivative of the inside, because that's the chain rule. And then if you simplify this out, well, the -1/2 times -2x, that's just an x on the top. And then this would be a square root of, oh, that was kind of ugly. Let me redraw that here slightly better. It'll be a square root of 4 minus x squared cubed. So this is g prime of x written a little nicer, and you set that equal to 0 to find the critical point. So if you look at the bottom here, so let's first find when f prime does not exist. F prime does not exist when the bottom of the fraction here, because this is a fraction, the bottom has to be 0 for this to not exist. So that's when 4 minus x squared, sorry, so 4 minus, the bottom cannot, for the bottom to be 0, 4 minus x squared would be equal to 0. You solve for x squared is equal to 4, x is equal to plus or minus 2. So this is when x is plus or minus 2, f prime is d and e, so we think this is a critical point, right? But however, there's one exception. You see, if you plug in 2 or negative 2 into the original equation, that's just not possible because the original function is not defined at that point. So it's impossible for it to be a critical point in this situation. Again, if you plug in the 2 or negative 2 into the original equation, you can't do that because that you would get an over 0 in the original. So we would actually cross this one out here. We cannot use that one. So let's look at when f prime of x is equal to 0. That's when the top is just equal to 0 of the fraction for g prime of x. Let me just write the g prime of x here again. So x is equal to 0 is the only place where you have a critical point.